Thank you, Rafael, for being part of XROM, which is India's first AR/VR MR podcast. So, a small introduction. So, Mr. Rafael Pages is the founder CEO of Volograms, which is a spin out from Trinity College Dublin. Their mission is to bring reality capture closer to everyone. Vologram uses a set of videos taken from different viewpoints and transforms them into volumetric holograms that can be enjoyed in virtual and augmented reality. The system works with different camera configuration, outdoor or indoor scenarios, and can even generate content with videos captured with handheld consumer devices. They are building the first software-only, hardware-agnostic, scalable, volumetric video creating platform. Thank you, Rafael, to be part of XROM, India's first AR/VR podcast. Really honored to have you on the show. So let's start with your background. Give a little bit brief on your background and the company's background.
Well, thanks so much, Eddie, for having me in the podcast. It's an honor to participate here. And yeah, I think it's a great opportunity for me to tell you a little bit more about my background and also about where Volograms comes from. So I'll just start. As I was joking earlier with you, as you can tell by my accent, I'm not Irish, even though Volograms is an Irish company. I am actually from Spain. I'm an engineer and not a let's say more like a researcher. That transition into becoming a founder of a company. So my background, as I was saying, is in computer vision and 3D reconstruction. I did my PhD in these areas, specialized in reconstructing humans, using different types of camera setups, like let's say sparse camera setups in the person from different viewpoints, but also using the Kinect. So this was almost 10 years ago when I started, and when I finished my PhD, we already had the Kinect 2, so I had to fight with depth sensors from the very beginning, since kind of the origin of the times. and then when I finished my PhD, what I wanted is to continue working in research and academia initially, or mostly what I wanted is to continue in the space. So I thought that 3D reconstruction was becoming a kind of a significant field with kind of new software coming up to do photogrammetry, to do all the types of 3D reconstruction. And I thought that there was a potential, a good way for me to continue my career. And I saw an opportunity to move to Dublin to start working in a lab called vSense. The lab was basically led by Aljosa Smolic, which is a very well-known researcher in the space. He was coming from Disney Research, which, of course, as you know, Disney always it's a good blend between academia and research, and also applied research, because almost everything they develop there ends up being integrated into the movies or into the games or into the amusement parks, right? So for me, it was a great opportunity to continue my career in the space, and that's what I did. So I moved to Dublin and I started working there, and actually vSense, which is the name of this research lab, became, let's say, the seed of Volograms, right? So this links a little bit with what Volograms is, or where it started. So when we started over there at vSense, what we were trying to do was, if you remember The Matrix, right, the movie, at some point Neo jumps and you have the bullet time shot with the camera spinning around. So we were trying to replicate that, but with a incredibly low cost setup. So we were trying to do it with 5 or 6 phones only, and replicating the movement of the cameras. And the phones were going to be handheld, and there was not going to be a control environment, so outdoors, and the phones were going to be different, and some of them were going to be portrait, landscape. So it was all the tough conditions into one single problem, right? So in order for us to be able to replicate the movement of the camera from one phone to the other, first, of course, we had to track the positions of the phone in space. We had to do foreground, background segmentation, a lot of stuff to isolate the person that we were going to be doing the scan of. And but in order to be able to replicate the movement of the cameras, the view synthesis, right, what it's called in this Free-Viewpoint video world, what we needed to do is a 3D reconstruction of the person that we were scanning, that we were kind of filming. And then we were still only having like 5 or 6 cameras, so we needed to develop our own algorithms that would work in such difficult conditions. So it turns out that the algorithms were actually pretty good. So we ended up getting really nice results, even with 5 cameras that were handheld, far from the person and stuff like that. And we started putting the assets that we were generating not only in this, let's say, free viewpoint video scenarios, but also more in like, we had the HoloLens in the lab, so let's put it in the HoloLens and see it on the table. And then we had, of course, the Vive back then, the HTC Vive, and we would put it in VR and just playing with it and doing as many experiments as we could. And we started seeing a lot of interest from people like, hey, could I do this with, more cameras, or could I put this into, a bigger stage, or can you have several of these guys? And then we thought, okay, maybe this is an opportunity. So back then there was only like maybe 3 or 4 companies in the volumetric capture space. So you had 4DView, SADI, Microsoft, of course, and probably Scatter, which was doing DepthKit. And ADI was probably the biggest at that time with a lot of funding. So we thought, okay, what is the common point between all these competitors? Is all of them had really massive cameras, probably except for the DevKit, really massive setup of cameras. And we were doing it with just like 5 or 6 phones, right? So it's like, okay, maybe there's some space here to commercialize a technology that would focus on people that has this very small camera setups, or maybe they have some camera setups because they were doing 360 video or something like that, or they were doing other kinds of experiments. So people who are actually creating the content but cannot really take a flight and go to, back then it was going to San Francisco or going to London or going to LA. That was basically the very few options that you had. So what happens about all Spain, all Europe, that there was like one studio in all Europe, which was Dimension, right, at that time. So what we were trying is actually to offer something for all these creators. So to get started, we set up like a tiny studio using only 12 cameras here in Dublin, and we started operating it commercially. And that was kind of the origin of Volograms.
Lovely, super. How cool is that? And I guess, you said you started as an engineer. Your background is computer vision and 3D reconstruction. Now you've become an entrepreneur, and you're fronting the volumetric capture ecosystem in Europe. You mentioned about the Dimension studio in UK. So yes, this is just the beginning of what the future is coming. Now, just from our audience who don't know what volumetric capture is, could you kind of break down, everything, right from your monoscopic VR to stereoscopic VR to photogrammetry, your static static capture, to volumetric right now. Could you just break it down for
Yeah, so volumetric capture, or volumetric video as the industry is calling it, it's basically a subset of what would be free viewpoint video. But anyway, so what the volumetric capture is basically a technology that allows you to capture a human performance, so a person that is moving, that is acting in full 3D. This means that then you can move around, see the person from any viewpoint, and then you can integrate the models that you end up having into any immersive environment. So VR, AR, and all the things like virtual production, visual effects, video games, or anything like that. But if I go from let's say the beginning to where we are right now, typically what you at the beginning with the first few years of VR, what we had is what people call 3 degrees of freedom VR, which is basically that you can only move your head around, rotate it, and you cannot really get close to the stuff. So that was kind of when 360 video or omnidirectional video was very popular. It's also because it was very easy to capture content using 360 cameras. Of course, there was different levels of quality and of resolution, and there was also an additional step, which was let's say stereoscopic 360, where you already have like a little feel of a depth, like a disparity between the eyes, so you can feel there's depth, but you cannot still get close to the things. But 6 degrees of freedom VR, and that's actually when you can not only move your head around, but you can also walk, let's say, in the space, get closer, bend down and see things from different viewpoints. And in that case, for that case in particular, 360 video doesn't really work because the things move with you, and then you lose a little bit the sense of the immersion, right? So most of the content that you see when you are in 6 Degrees of Freedom VR, which is, by the way, it's mainly what everything is right now. So when we started at the beginning with, the Google Cardboard and the Samsung Gear VR and things like that, those were all 3 Degrees of Freedom. But now the Quest and all the like high-end VR headsets, they are all 6 Degrees of Freedom, which means that they track you in the space, so you know where you're moving. So the content that you see in there, it's typically generated by an artist, let's say. So it's a fully immersive environment. Sometimes most of the times it's designed, so it feels like a little bit like a cartoonish world. And sometimes it's very realistic because it is actually based in reality, which means that somebody went somewhere, captured the space in 3D, and then brought it to the application. And the technique that typically is used to capture the world in 3D is photogrammetry, which is that you go with a camera, go and take a lot of photos, with the idea that photo after photo, there's an overlap between the images, and then you can run the photogrammetry algorithm that will give you the 3D shape and appearance, because it would also apply some texture map on it of whatever you're scanning. So sometimes it might be some rocks, a landscape, a building, or it could be almost anything. And you can use those realistic assets in your game, in your application, and your experience. So that would already make you feel a little bit more immersed, because once you're in VR, if you're seeing things that are actually from the real world, it looks a lot better and a lot nicer than when it's something that is designed. And photogrammetry is being used lately almost everywhere. In movies, it's used in games, it's used almost in any application. But what happens when you want to capture a person, right? So when you were in 360 video, you were using standard cameras to capture everything that was around you, pointing outward, so you can just capture anything. But now that you're in 6 Degrees of Freedom, you can move around. You cannot really capture the people in the same way. So you typically have a few options. One is that you have a virtual character that is designed by an artist, again, which means that sometimes it's very nice, but still a little bit cartoonish. But if you want a real person, you have two options. One of them is do a very high-end 3D scan of a person and then animate it and rig it, which is typically what it's done in games or what it's done in a lot of movies. But the problem with that, especially in VR, is that when you get close to that person and that person is speaking and talking, it's kind of weird sometimes, because that animated character is not going to move the eyebrows the same person does. It's not going to get the same wrinkles. It's going to fall very quickly into what in the industry is called the uncanny valley, right? That it's very realistic, but it's not fully realistic. Then it's incredibly weird when you look at the model. So that is an option, definitely, but for us, it's nothing compared to actually doing a volumetric scan of a person, a volumetric video scan, because in that case, everything that you see is based on video. You have captured the person from many viewpoints, from all perspectives as possible, and you can see everything because the colors, the texture is based on the video that was recorded. So you will see the wrinkles when you're moving, you will see the dimples when the person is smiling, and you will see every little detail. So that is why volumetric video, volumetric capture makes so much sense, specifically for immersive applications, VR and AR.
So you said that when you started with around, tinkering around with 5 or 6 cameras. And now obviously, with the help of technology, which is growing exponentially, there are people who are doing some seriously awesome thing. I was just watching this video, this guy called Howley. He's creating volumetric capture with just one camera. How amazing is that? Now, can you tell me more details about Vologram? Where does it stand at this point in time? And what makes your company unique? What is it that you offer with what your peers don't do?
Yeah, sure. I'm a big fan of Howley. So he does a lot of very cool research, it's something that if you've been in academia, I've of course studied the papers and seen what other people are doing. So big fan. So I would say that the key difference with Volograms with respect to all the players in the space is let's say, the business model, but also how we are approaching the problem. So, for instance, the way that you will have some other of our competitors, although anyway, I have to say that I don't consider them competitors, really. I think the space is still relatively small, and then what we have to do is kind of make the pie bigger instead of fighting for the little pie that it is right now. So I actually think that when we talk about with the other leaders of the other companies, that's the view that we all share, right? That this is a space that still needs to grow. But what other companies are doing is basically licensing a full product that includes a set of cameras and includes like a software package, and in some cases it might include some additional things. With that you install it in your location and then you get your models. That's perfect. So what we're trying to do is completely different. So even though we like this approach and we think that approach is very valid and it's working, that approach is not really scalable. So we don't think that you can set up 2,000 Microsoft Studios in the world. I think that the technology is still too complicated. So what we're trying to do is trying to simplify the different areas where the technology is still too complex. So one of the key problems that you typically have when you do volumetric capture is the amount of data that you end up having and having to process. So this means that sometimes when you're doing your, let's say, 3D reconstruction algorithms, it might take hours, in some cases days, in some cases weeks, depending on how long the sequence is, and also depending on where you're doing the processing. So if you're doing the processing in a normal standard computer, you can just forget about it already. So you always have to need like a server, in some cases multiple servers, to be able to render that stuff. And we know that creators don't have like server rooms. They sometimes do rendering on the cloud, on demand, and other places. So the first thing we did is, or one of the most important things we did, was putting our 3D reconstructions algorithms on the cloud. So if you have a setup of cameras because you're a creator and you know nothing about 3D reconstruction, you don't need that huge computing power. You can just do everything on the cloud, which means that you don't have to worry about your computers, let's say. The other thing that we saw is that, of course, buying a couple dozens of cameras or hundreds of cameras, as in some cases, it's definitely a barrier. So as we had started, as I was telling you earlier, with 5 or 6 cameras, what is the minimum number of cameras that we think people can use to get a decent full body 3D reconstruction? And so we set up our studio with 12. And we think that's like the bare minimum that you can get with our technology. But 12 cameras is a very reasonable number. We've seen with some of our clients that sometimes they're even able to rent the cameras. So you actually can go to somewhere, rent 12 cameras and put them together, do a shooting, and then return in a couple of days afterwards, which means that let's say the hardware part of the problem gets a little bit simplified because you don't need to set up like a massive studio or anything like that. And then the last thing is it's how expensive it is. So the problem with most of the companies or most of the people that want to get into the space is that sometimes they see that this is a very expensive thing to do, and it is very expensive because it's a lot of processing, it's a lot of time that it takes, and it's a very specific type of technology. So what we wanted is, okay, if we can offer this to as many people as possible, we can do the reconstruction on the cloud, we can put the prices down so it's more accessible to anyone. And at the same time, if you're let's say a creator that does 12 projects a year, just for example, where 2 of them have volumetric video, instead of forcing you to buy a license that you have to pay every year or anything like that, you only pay for the projects that you do. So this means that it's more flexible for you. Some other things that are interesting from our system and that are derived, let's say, from the versatility of the algorithms is that you can also set up different types of capture subsystems depending on the type of content that you need. So say that you only want to capture faces because you have your setup, you're doing a game, for example, that it's going to include astronauts or something like that, right? So you have already a very nice astronaut suit that you have designed, futuristic, perfect, but then you want a very realistic face. So you can do volumetric capture of just the face. And for that, you don't need 100 cameras. You can do that with just 5 or 6, and that will be more than enough. So there's no need of actually building like a massive setup to do volumetric capture of faces. And right now, there's not really a really good alternative for you to go and do, let's say, face. When I say face, it could be like half body, it could be multiple people. What we want is our system to be able to support all these creators and adapt to their pipelines instead of them having to adapt to us. So that, I would say that those are like the key differences.
So how is it cost effective? You said it takes minimum 12 cameras at this point in time. That there are these players who are actually taking single depth sense cameras, or maybe 2 or 3 depth sensing cameras, and daisy chaining them, to build like volumetric capture. And that also works out. So how is that cost effective compared to what the solution that you offer?
Yeah, so I would say that, well, when I was doing my PhD, I had to fight a lot with depth sensors and all this type of cameras, and that maybe a little bit biased towards not using them. I think that depth sensors are great. I think the technology, that the capabilities that they provide are awesome, but in my opinion, they're still not great for volumetric video. Specifically if you use multiple of them, because there's some problems that you probably don't have in mind whenever you get started. And I think that's one of the issues, and that maybe sometimes developers get frustrated with, that they say, okay, I saw the new Azure Kinect, it's awesome. I'm just going to buy 10 of these and put them together into a computer. And then you realize that the amount of data that they transfer is so high that you need several computers to be able to use them. And then there's synchronization problems, because you suddenly realize, and I don't know specifically about this Kinect, but I know about all the older Kinects, that they have interference with each other. And then you have problems with that, and holes, and then it's noisy. It's not really good in temporally. So there's so many problems with or so many challenges, let's say, with the depth sensors, that I see that it's very complicated to get to a result similar to what the high-end volumetric capture companies are getting with depth sensors. That's my opinion, right? So yeah, you can get started, you can play a little bit with it, and if you want to give it like this artistic twist and just embrace the noise and let's say the flickeriness of the depth sensors, go for it. I'm a huge fan of what DepthKit is doing. That's basically perfecting this. And they're one of the companies that have been for the longest time in this space. So, but I don't think that you can get to the level of quality that Microsoft is getting using depth sensors. And so when I say cost effective, it's because I'm assuming that you're looking for something that looks like that and not something that looks like a depth sensor. And then we say we're more cost effective because you don't need to pay like a full license to get into the space. You don't need to, you only pay for whenever you need to use it. So for you, sometimes it can be as cheap as hiring some professional to edit a video for you.
Right. So tell me, how does your partnership work? For example, there's a content studio now. Maybe the content studio is based out of India, and now they're looking at partnering with you and creating a volumetric capture usage. So how does it work? How do you guys come in? What's the payment plan? How do you sort out does the content studio end up? He's got to buy those 12 cameras. What's the procedure? How does that work?
Yeah, so the process typically starts with the company contacting us. So it depends a little bit on what is the application that's going to be used for. So if you're looking for, let's say, capturing full body humans for doing specific type of movements, we will recommend you what we think is the minimum number of cameras that you should get. Sometimes it might be 16, or sometimes, depending on what you get, it might be 50. But in general, we try to keep it low, right? So we would recommend you what we think you should get. If you still don't have them, we'll show you more or less what type of cameras we typically use and things like that, even though in general we work with any camera. So any camera that is, of course, able to record video. And then once you've decided what you want to set up and you put it together, you buy it, or you just organize everything, we will help you calibrate it, and we will show you what type of results you're able to get. So calibration, we have our own method that it's a pretty standard system that it's automatically estimating the positions of the cameras in space. And with that, you should be able to already get an idea of what type of reconstructions you will be able to get. So you can decide if you want to buy more or remove some of the cameras. So once you're ready with that, every time you do a capture, you just upload to our platform the video that you want the reconstruction, so all the videos from all the cameras, and with that you will get the results. So what you end up paying, it's only for what you've reconstructed. So the pricing model depends a lot on several things. It depends. It has a price per second of volumetric capture, but there's a minimum of seconds that we will charge, and then there's a depending on the number of cameras you use. Because of course, if you use 100 cameras, then there's a lot more information. It's gonna take us a little bit more time to get it, but depending on the time, and also if it's a one-off type of project or if it's something that is recurrent. So depending on that, we will give you one price or the other. But the key thing here is that you build the setup that would work for your specific needs, and in some cases you might even already have it. So there's some of the companies we're working with are studios that were doing already photogrammetry, like static models of humans, and they were using them for 3D printing, or they were using them to analyze the clothing because they are in fashion or something like this, and they didn't know they could get into volumetric and kind of expand their services. Or in some cases they had tried and discovered that photogrammetry frame by frame is not the same as volumetric video, and there is like another massive problem that is attached to that, which is what you do when you have like hundreds of thousands of 3D meshes with textures and so on. The amount of so how can you compress that? How do you fix the temporal consistency? Things like that you at the beginning never think of. So some of our clients already had the cameras and already had the setup. We just provided a solution for them.
Right. So once you capture the data, you have the subject or the asset captured. Now, if you want to compose it into like a live action or a CG computer graphic system, how does it work? How does the lighting work? How difficult it is? What tools do you use? What software do you use to composite these files? How do you?
Yes, of course. So once you have done the reconstruction, we have our own format that basically compresses the sequences. I put them in a relatively small footprint compared to what it would be if you have like every model with its texture, with a video texture. So this means that you can integrate them more or less easily into almost any pipeline. We do have a plugin for Unity, so you can just use Unity straight away. The models have normals, so this means that you can change the lighting and adapt it to whatever lighting your scenario has or in your application. We're now building also the Unreal plugin because we got one of these epic grants, the mega grants. So we're now building this functionality, and it will be released soon. And but you can also get typically one of the things that we always get asked is if we can get the raw model. So this means all the frame by frame 3D models. So if you have the 3D models, then you can put them into Blender, you can put them into almost any other environment and do some other, let's say, rendering that it's not real time, which is pretty good for, let's say, visual effects and things like that. So you can also import them into almost any software that you want afterwards.
Right. So what are the current challenges facing volumetric video? This is definitely the future. I think in the next couple of years, I mean, everything, all the technologies, right from spatial technology to AR, augmented reality, virtual reality, mixed reality, everything, 5G, everything is gonna enable us to get into the 3D world, the spatial world, the computing world. We're gonna jump from a static 2D model to in the 3D spatial world. So this definitely, I think, is one of the most awesome technology, which also has huge economical benefit out there. It could well as much be a multi-billion-dollar industry, but what is the current challenges at this point of time, and when do you realistically see volumetric capture being a reality?
Yeah, so totally agree with you. We always say that volumetric video could be as important as the cinema was at some point, right? When you were able to record the world in 2D for the screens, and this is the way to record the world in 3D, and actors but for the next computing platform, which is going to be AR or immersive computing, spatial computing. So I totally agree with you. I think it has a massive potential. We think that this could become like a multi-billion industry, and the content generation industry, you know that it's huge and it's growing. So generating content in 3D, it's even more important than ever. There's many challenges though. So I think I explained a few of them when I was trying to tell you how we want to make this more accessible to people. So one of them, as I was saying, is how accessible it is to get into the space. So can you do it with a reduced number of cameras? So that would be like a hardware challenge. How fast you can do this, so you don't have to wait hours. But once you have the models, there's other challenges, right? Like we're talking about distribution, how you're gonna distribute this content, which is, I think, it's an analogous problem to what in general AR applications have. I really like, for instance, what Ethwall is doing, that they're building like everything that needs to be built, so you can do a lot of AR and a lot of immersive content directly on the web. Trying to tackle specifically this problem. There's also post-production problems, right? So once you have the assets, what if you want to change them? What if you want to retouch them? So there's a bunch of companies that are popping around, like Arturus or Sense of Space, that are specifically focusing on the post-production of the volumetric content. So the fact that these companies exist is a good sign that the market, let's say the business and the demand, is growing, because there's more people who need them. But there's many other things, like this type of content right now is very tied to immersive stuff. So as long as the immersive world is not fully mainstream, this type of content is not going to be fully mainstream either. I think that for now, it depends also a lot on what you consider a success. So if you, for instance, think about cinema cameras, this is something that it's only for the movies, and they're very expensive and it's very niche, but they're a success. I think that volumetric video, it's in the right track to becoming a very big success for professionals. And the next step would be for the rest of the world, right? How do we do this with fewer cameras? How do we make it as accessible as possible? So instead of having 5 volumetric capture studios in Europe, you have one in every city, in every big city, or how do we do it that at some point everyone is able to capture their own content with the new sensors on the phones, or using multiple phones or anything like that? I think that's the real challenge, and I think that challenge will be very tied to whenever we get the next AR glasses that actually look like normal glasses, because at that moment there's going to be a huge demand of more content and better ways and easier ways to create content, and that's where we want to be.
Right, yeah, and I think we are quickly moving towards that future where a computer and a mobile is going to converge into a single wearable device. Apple, Facebook, Jio in India, and so many others are working on building a glasses, And if things go on track where they are pushing, I think 2023 we should have some really good quality AR headset. So can you talk about some of the present day use cases for volumetric capture and some of your partners who you've built?
Yeah, sure. I think sometimes I give I answer these questions in not in the best way, right? Because I want to say, okay, we are creating, not only us, everybody else in the space, we are creating the camera, let's say, or the software, and then the use cases is like whatever the creators do with them, right? So we don't want to work towards specific use cases. We want to enable people to build their own use cases. But it is true that there's some pattern, and there's a few areas that have been more active in this space, and we've done marketing campaigns, with some of them with celebrities. We've done a lot in the cultural space. So we did once like a theater play, and we've done a few applications for different museums and cultural sites, including a few in Ireland here, and one that it's upcoming in London, happening probably the beginning of next year, if COVID lets us. But we've also done training, we've also done educational stuff. And we are now getting into sports and some other areas like this, where you having visualizing the content from the different viewpoints is really interesting. And there's, I think that all the companies in the space, including us, we're doing a lot of corporate communication type of stuff. This is the thing that typically don't go out so often. But we've done, for instance, a live event presentation where somebody was wearing the HoloLens, and it was broadcast to a screen where everybody could see the hologram of the presenter there. And we've done also like projects for internal projects for companies where you want to show the facilities, the new facilities that they're building, or they want to communicate something to the employees and things like that. This is very typical in this space. I think that there's now there's like the next step, which is how do we bring this to the masses, right? And this is where I think the distribution platforms that start getting a lot of value. And you've seen, like, for instance, a few examples with the president of Israel that the company called Tetavi did, where they embedded into a website. So this means that a lot more people can access to it. And I think that's actually what it's going to take what's going to drive the next generation of volumetric experiences. So yeah, I think that, whatever you can use, whatever you can use humans or humans acting or performing, then there's a valid use case for volumetric capture.
Yeah, so I'm with you on that, because yes, I'm super excited about where the future is going. I think in another couple of years, the way technology is going, everything which is was magical is going to become a reality. Because that's where technology is going. We want to be getting over from a 2D medium and getting into the 3D world. As weird it might sound to the people who don't know, about the spatial computing, but this is a reality, and we are getting in there in the next few years. Now tell me, the only ways to get this, for the mass is, when you democratize it, where you get, all content creators, you give them this tool, and then you tell those content creators that, oh, look at this is the tool, you are no longer restricted with the 2D medium. Here, you can walk into the content, interact with the content. How magical is that going to be? How long do you think that's going to take? And when do you think we are going to see the first Hollywood volumetric film?
Good question. I think that you have already seen volumetric capture in Hollywood, but not in a 3D movie, or in a, let's say, immersive movie. So the volumetric video has already been used in some Hollywood productions, but mostly for characters in the background and things like that, where it's very versatile to have the digital assets instead of having real actors. So yeah. I think that for Hollywood to get to see the first volumetric movie from Hollywood, you would need to at least see some Hollywood content in VR, and I think that's for now. I don't see that Hollywood has had a lot of interest into building like a full experience there. I think that most of the good storytelling experiences and stuff like that we've seen in VR come from smaller studios that are a lot more creative and willing to risk and willing to create something that is really meaningful. So, and there's plenty of experiences that have volumetric capture in them. So regarding when do I see that this is going to become like a fully mainstream or something like that? It's funny because that very first thing that you asked me was, what is volumetric capture, right? And I had to give you like a technical explanation of what it is. But everybody really knows what it is. The problem is that they don't know that this is the term that we're using in the industry. I mean, everybody has seen the Princess Leia, help me Obi-Wan Kenobi. And that is volumetric capture done by R2-D2, who knows with what type of sensor or whatever. But all the holograms that we're used to seeing in the movies, they had to be captured somehow. And the way of capturing these holograms is actually volumetric capture. So when you see all these science fiction movies putting holograms in space or people wearing glasses and suddenly seeing people around them and so on, I think those two things are very tied. So I think this 3D content is native to the 3D environment. So it's native to spatial computing, immersive computing. It's native to VFX. It's native to games, things like that. So even though I really like like 360 video and stuff like that, I think where you can really take advantage is when you are in the 3D space, when you are in augmented reality, when you are in anything like that. So I think with the growth of augmented reality specifically, we will see a lot more demand for the content creation. And that is where volumetric capture is going to catch up, and we will continue developing and lowering the barriers to entry. I hope that we are able to lower them even more within the next couple of years. But I believe that whenever there's the new glasses that are really look like glasses, something that is not a headset, let's say, I think that is the moment where we will start seeing a lot of growth and a lot more ways of creating content. And you can see an analogy with a mobile phone. So yeah, there was, when I was in high school at the early 2000s, I had a phone which had a camera. It was a Nokia phone, but I took a photo every now and then because the quality was not great. But not only because of the quality, it was because there was not the ecosystem to share those images directly from the phone. So then with the iPhone and an Android and a new wave of applications that could take advantage of the camera, it's when suddenly the camera became like the center of the phone, right? Is what suddenly created Instagram and Snapchat and TikTok and all these big companies that suddenly are huge monsters, and they are all around content creation with the camera of your phone. So there needs to be first a device where you can fully take advantage of the 3D environment, and so you can build an ecosystem around it. And volumetric capture is going to be fundamental in that ecosystem.
Right. So amongst your peers, whose work you're most excited for? Because there is some really, really cool things are happening also, and at the same time, sad things like Intel had to shut down. Google is doing some really cool stuff. Sony is doing some really cool stuff. Microsoft. So what excites you amongst the work that you've seen amongst your peers?
Well, there's so many things that are exciting right now. For instance, I'm a huge fan of the Looking Glass company. I don't know if you've heard of them. We were backers of the first campaign, and I just got another one in the new campaign. I think that those type of screens are going to be everywhere. So it's not everything's going to be on the headset, and we need to have both things, right? So again, I go back to the Princess Leia, but nobody was wearing a headset in Star Wars, right? So this means that there needs to be other ways of displaying the content, and I think this is a really great start. It's also, they made a huge effort to make it incredibly simple to integrate and to show the stuff. So if you know how to use Unity, it just takes 5 minutes to do. And now with the new setup, the new device, they have even an app where you can just send the content and you can already see that, let's say, volumetric content. So for us, it's great because sometimes, I don't know, you're in an exhibition, a fair, and you have there your little booth, and you, of course, have to bring there a lot of, let's say, phones, iPads, things like that, so you can show the content in AR. We sometimes bring a couple of Magic Leaps or a couple of VR headsets. But yeah, it's very slow. You have to put it to people and explain what they're seeing and things like that. While if you have like one of these screens on the table, everybody goes and says like, "Oh, that's so cool, right?" Like, and you can see it fully 3D. You can take it. You can see the characters moving, look around, and it's incredibly good to see how. I really like how the reactions of the people is, and it's a great way of showing content. I think that's going to play a fundamental role also in, let's say, immersive communications, right? How you're going to use real-time volumetric video with maybe depth sensors or whatever. So I'm really excited with this type of non-headset, non-phone augmented reality or ways to display holograms. That's probably my favorite.
As a startup, I do not have to be restricted to engineers or developers only from India. I can reach out to pockets in Bangladesh, I could reach out to pockets in China, or developers anywhere around the world. And I feel that collaboration is the future, because when you work in silos, you are not growing the technology or accelerating the possibilities of what could happen. So how do you see India as a market opportunity? Are you looking at collaboration, and what is the future roadmap vision for you and for Vologram?
Yeah, no, I mean, it would be stupid to kind of not think about India as the future. You're one of the countries with the highest density of population, and therefore a lot of people that you can address with these immersive technologies. We actually have two members of the team that are from India, so we always have India in our hearts and in our minds. I think that that's something that probably European and maybe American companies don't do really great is actually Asia. So it's I think Asia for us is like the great unknown, and sometimes it's so culturally different that it's for us very complicated to have it in the top of our heads. But it would be stupid to completely ignore them, and we've always, as I was saying, as we have members from our team from India, always thinking about how can we get there, how can we give this to more people, because sometimes that is the difficult part, right? Like finding a lot of people that are willing to test this, and we've seen that all Asia, but specifically India, have a massive potential in the AR VR worlds, and you guys have a pretty good engineers and a lot of artists there, so it's incredibly, you have everything you need to become one of the leaders in the space, and for us it would be great if we could establish a partnership over there and start creating content that is specifically for the Indian people, and well, I haven't even mentioned Bollywood or anything like that, which is a huge market also, and so yeah, I think that you guys have everything you need in order to become a huge success, and I really hope you do.
Thank you. Thank you, Rafael. Wish you the very best too for the future. It looks super exciting. What you are doing could be the groundwork or the framework for the future of or 3D world, and I am super excited about it, because there is so much cool things happening right now, and this natural disaster of COVID has kind of accelerated or put a spotlight on everything which was on a creeping mechanism. All the technology which was on a creeping mechanism suddenly has got the spotlight, and people have understood that this was not the first time that something like this, a natural disaster, has happened, and obviously it's not going to be the last. Are we going to be the same way caught unprepared, or be a little prepared in the future by already digitizing, being ahead with technology, is what will chart the future of the entire civilization. Because I think we need to understand that all of these technologies are the frameworks for what is coming soon. Accepting change, we are always reluctant to it, but I think there are some really cool things happening, and we all need to come together. You mentioned about Bollywood, and I think it's a super exciting space. It's one of the biggest industry here in India. Today, the entire theater industry is disrupted. People are moving towards OTT. Maybe in another few years, everything's going to move on to a wearable device where content, your offices, everything is going to be in a 3D world. So I am excited for that world, and that's the reason I'm doing whatever I'm doing. Wish you the very best for Vologram, and I hope someday we can collaborate, maybe and do something really cool. On that note, to my listeners, if you like what you see in here, please put the subscribe button. Until next time, see you guys. Bye bye. Thank you.
Thanks so much for your time. Thanks so much for having me today. It was a really interesting conversation. So sometimes I don't get like a full hour to explain in every detail everything that we do and everything that we want to, or how we see the future. And today I had that time. So thanks so much for giving me this opportunity. And I hope that you also have a really good beginning of the year, that it's coming in the next couple of weeks.
Lovely. Yeah. You very happy 2021 to you. Yeah. You take care. Cheers. Bye.